Welcome to the second lecture on energy demand. First, let's talk about energy efficiency policy and the rebound effect. So what is the rebound effect? What happens when we reduce the energy intensity of a durable good? The price of the energy service falls. So the energy intensity of a durable good, maybe a car, would be the miles per gallon. So we're going to reduce the energy intensity, meaning we're increasing the fuel efficiency or miles per gallon. So the price of driving the car is going down for every mile that we drive it. Well, the law of demand says that as the price of the energy service falls, the quantity consumed of the energy service must then increase. This is simply the downward sloping demand curve. As the price falls, we consume more of the good. So the definition of the rebound effect is that is the increase in the consumption of an energy service due to an increase in the energy efficiency of the associated durable good. So when we increase the fuel efficiency, we're going to drive cars more. So the takeaway is that policies that promote energy efficiency, or something like a fuel efficiency standard, may be less effective than we might hope. So if we don't consider the rebound effect and we implement a fuel efficiency standard and increase fuel efficiency on average, we might assume that there's going to be less gasoline consumed. But what we're not accounting for is the fact that if the price of driving goes down, the reduction in gasoline demand might not be as much as we initially hoped for if we don't account for the rebound effect. For example, if we swap an inefficient car for an efficient car that uses less gasoline per mile, like a Jeep for a Subaru, or maybe a truck for a Prius, then the price for each mile driven decreases. It becomes cheaper to drive the same distance. So again, by the law of demand, this will lead to an increase in the total number of miles driven. Econ 101 review, the price elasticity of demand. So again, the law of demand, all else equal, a higher price for a good or service leads people to demand a smaller quantity of that good or service. The price elasticity of demand is equal to the percent change in quantity demanded over the percent change in price. So for any given change in price, how much does the quantity demanded change? Demand is elastic if the price elasticity of demand is greater than 1 in absolute value, and inelastic if the price elasticity of demand is less than 1 in absolute value. The symbol epsilon is often used to represent an elasticity. So which of these two demand curves is elastic and which is inelastic? You should ask yourself this question. If you don't know the answer, go back to your Econ 101 book and figure that out. Demand curves of the form QP equals AP to the epsilon have a constant elasticity. These are somewhat convenient demand curves. They're called isoelastic or constant elasticity demand curves, and we'll sometimes use these demand curves in this form where epsilon is less than or equal to 0. So epsilon is a negative value. We often report demand elasticities in absolute values, so they look positive, but in reality they're negative because we know that the demand curve is sloping downwards. These demand curves have a constant elasticity equal to epsilon. They're convenient because it's easy to see what the elasticity is. In these two examples on this slide, the top one, QP equals 24,750 p to the negative 3. We know that the elasticity is negative 3. This is a pretty elastic demand curve. QP, the second one, QP equals 4p to the negative 0.2. The elasticity is constant at negative 0.2. And this is a somewhat inelastic demand curve. We will also use isoelastic supply curves. How can you tell which is which? How can you tell which is a demand versus a supply curve? The answer is that the demand curves have negative elasticities where the supply curves will have positive elasticity because the supply curves are upward sloping.